Part 1, GR, General Relativity, Definition and Properties related to the Cartesian coordinate, Classical Mechanics. Lesson 1, Einstein notation, free and dumb indices. You're going to learn Einstein notation. Let's give examples. Suppose I have a component AI. This I here, I, 1, 2, 3. This corresponds to R3, okay? Dimension 3. AI, I is equal 1, 2, 3. This is a free index. This corresponds to A1, A2, A3. Now another example, Bij. This is 1 free index. Bij, this is in R3, the components are B1, I'll do it like this, J, B2, J, B3, J. You see, I is equal to 1, 2, 3. Here, J, 1, 2, 3. Then this is equal to B, 1, 1. Now J. B, 1, 2. B, 1, 3. B, now J is equal to 2, 1. B, 2, 2. B, 2, 3. Now J is equal 3. B, 3, 1. B, 3, 2. B, 3, 3. So this is a two free indices. That's Bij, you see, correspond to 3, 6, 9. 9 components. AI corresponds to 3 components. You see, these are a free index. Okay? This component, independent component. Now, suppose I have a function phi. Okay? Here is no free index. No free index. Now we're going to learn about dummy indices. All this here, this example, I'll say free index. Now, dummy index, example. Okay. Suppose I have A, I. You see the difference here? Here I have 1 free index. Here I have 2 indexes. This is called dummy index. This dummy index, by definition, I just sum A11 plus A22 plus A33. So this here is a scalar. See, there's a sum of components. Those are components. Now, suppose I have A, J, K, K. This corresponds 1J, let's go like that. J is equal 1, 2, 3. This is free index. I, in this case, not I, K is dummy index. This is repeated, so it's dummy. Okay? So dummy, I'll put right here, repeated indices. This is a dummy. A dummy, you see? Now, it's attention. Attention now. If I develop this, actually example, I have J is equal 1 because J is free index. Then I write A, J, K, K is equal to A1, attention now, okay, K, K, J is equal 1. This is free index. Then I'll sum like this. Okay. J is equal 1. I have 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3. You see, J is equal 1. Now, because it's free, J is equal 2. Now I have A, J, K, K is equal A2. Now I'll sum in K. 1, 1 plus A2, 2, 2 plus A2, 3, 3. You see, K is repeated indices. J is free index. Now, J is equal 3. Then A, J, K, K is equal A3, 1, 1 plus A3, 2, 2 plus A3, 3, 3. You see, this here is free index. This independent. Now, K, K, or I, or K, K, doesn't matter. You see, we denominate, in this case, dummy, because look at this, how interesting. I will raise KK here. I will raise KK here. I will raise KK and KK. See, look how easy. Then I put, for instance, P, P. You see, this is P, P. This is P, 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 P. Here, P goes to 1, 2, 3. There's a sum. The sum is the same. You see, that's why we call dummy index. Dummy means I can For instance, substitute this index here. Please, AJ, don't put here JJ, because you'll be quite confused, because J is free and PP is dummy. Don't put, substitute by any notation you want. Okay, just for you to understand, I'll raise here, I'll raise here, I will erase here, and I will erase here. Okay? I just set M, doesn't matter. Aqui, ó, look, M, you see, M is dummy. You see, the answer is the same. Doesn't matter. So this, I'll call an introduction, okay, to this definition. This is Einstein notation. Einstein notation, free and dummy index. When I derive, when I make order derivation, you see clearly the application of this Einstein notation. This is my lecture 1.